Welcome to an intro to integration by parts. So the idea here is essentially not all integrals can be solved with use substitution. So for example, if we wish to take the integral of x times sine of x dx, it will do us no good setting x as u, since that would just change it to an integral of u sine of u du. Right? So if x equals u, then we would just get integral of u sine of u du, which looks exactly the same, just a different variable. If sine of x is u, then we would have that du is cosine of x dx. And that doesn't really do us any good. We would get an integral of x would be sine inverse of u. And then we would have times u, and then dx would be a secant of x du, and then we would plug in sine inverse of u in there, and it would just get messy. It would become secant of sine inverse of u du, both of which are extremely messy, right? So we need another approach. Now, the u sub is basically an integral version of the chain rule, right? So recall u substitution is an integral version of the chain rule, essentially, or it's integration using the chain rule. It turns out integration by parts is an integral version of the product rule. So integration by parts will be an integral version of the product rule. So let's just start off with the product rule and see what happens when we integrate it. So the product rule states that the derivative of f times g is equal to f prime times g plus f times g prime. We are going to rewrite this with u's and v's. So rewriting with u's and v's, we have the derivative of u times v is equal to du dx times v plus u times dv dx. So if we now integrate both sides, we are looking at the integral of d dx of u times v, and then dx is equal to the integral of du dx times v dx plus the integral of u times dv dx times dx. Du dx times dx is just du. Similarly, dv dx times dx is just v, sorry, is dv. And of course, the integral of the derivative comes up essentially with uv plus or minus a constant, right? So the left-hand side, we can get to u times v. So the left-hand side becomes uv, and the right-hand side becomes the integral of v times du plus the integral of u times dv. Rearranging this, we get the rule for integration by parts. So the whole point of integration by parts is so that we can do an integral. So if we just rearrange the fact that uv is equal to the integral of v times du plus the integral of u times dv, we wind up getting that the integral of u times dv is equal to u times v minus the integral of v times du. So the whole thing here is essentially we need to break our integral or integrand up into a u and dv component. So we just need to figure out the appropriate u and dv, and then we can apply this formula. So again, this is just essentially the integral version of the product rule. It comes straight from the product rule. And it's that the integral of u dv is equal to u times v minus the integral of v du. So in the next video, we'll go ahead and look at some examples and see sort of an alternative format also to how this one is written.